Hello and welcome to today's class. If this is your first time of coming to this channel, I am Samuel. If this is your first time, I tell you to please like, subscribe, and comment. And if you are a returning subscriber, do well to comment and like. In today's topic, we're talking about scalars and vectors. In our last class, we talked about physical quantities and how they are being measured, and we talked about the fundamental quantities and the derived quantities. Now, physical quantities are also classified into two again. We have the scalar quantities and the vector quantities. Scalar quantities and vector quantities. Now, what about scalar quantities? What do you mean by scalar quantities? Scalar quantities are those quantities that have only magnitude without direction. Now, last class we were talking about there are some differentiated between mass and weight, and I made mention of scalars and vector. Now, when we talk about magnitude, what is magnitude? Magnitude is a numerical value of a physical quantity. For example, like you say you fill your gas, take 10 kg. The 10 is the magnitude and kg is the unit. So scalar quantities has only magnitude but no direction. Now, when we let's talk about vector. Let me give us an example of scalar quantities. Examples of scalar quantities are speed, distance, time, mass, length. Okay, distance already there. We also have temperature. These are examples of scalar quantities. There are so many other examples. Go to your physics textbook, you see them there. Now let's talk about vector quantities. Now, what about vector quantities? What are vector quantities? Vector quantities are physical quantities that have both magnitude and direction. There are quantities that have both magnitude and direction. Now, what are the examples of vector quantity? We have velocity. We have displacement. We have acceleration. We have force. We have momentum. Now, all these are examples of vector quantities. There are other examples of vector quantities. If you go to a business textbook, you see them. Now let's talk about these scalars and vectors. Let's analyze them very well. If you talk about magnitude and direction, like I said before, mass. If you talk about the mass of an object, it has only numerical value, but it doesn't have direction where it's what? Acting. Now, if you talk about the weight of that mass, it has what? Direction. It has particular place where it's pointing at. It's moving downwards. Now, force. Force is a vector quantity. Now, we say a force of 10 Newton. Now, if you say a force of 10 Newton, 10 is numerical value, and then force has a direction where it's pointing at. Weight is already a force. Now, if I say, if I apply a force on a body, or I throw an object with a particular force, it will do what? It is going in direction of the what? Force. That's why Newton's second law of motion states that rate of change of momentum is proportional to the force and moving the what? Direction of the what? Force. If you apply a force, what when you're pushing a car, the car will move in that direction that you are what? Pushing it. Or if you are pulling it, it comes to what? That direction. Now, for example, let's talk about displacement. Displacement is distance. Displacement and distance are the same thing. But the difference there is that distance is just a numerical, that has only numerical value, but displacement is what? It has a specified direction. For example, if they say somebody somebody moved a direction of 10 kilometers. 10 kilometers north, 45-degree east. This is a what? Displacement. Why? It has direction. But this was only this 10 kilometers is what? Distance. So displacement is a vector quantity. Now let's talk about the similarities between vector quantities and scalar quantities. Similarities. Similarities between vector quantities and scalar quantities. Number one similarity between vector quantities and scalar quantities is that both of them are physical quantities which are used to measure or describe phenomena in physics. Both of them are quantities that are used to describe phenomena in physics. Now, another example is that both have what? Magnitude. Now, for example, they say speed. A speed of 10 kilometers per hour. Displacement. 10 kilometers north, 45-degree east. Both of them has what? Magnitude. Both of them has magnitude. Now, another similarities between scalars and vectors is that both of them has units. Now, speed 10 kilometers per hour, displacement 10 kilometers. This kilometer per hour is what? Units. So both of them are units. Another similarities between scalars and vectors is that both of them can undergo mathematical operations like addition and subtraction. Both scalars and vectors undergo mathematical operations, though vectors differ. What do I mean? In scalar quantities, they are being added arithmetically, while vectors are being added using vector method or vector rule. We'll come to that. Now, this is about the differences between scalars and vector. Number one difference between scalars and vectors is that scalar quantities have only magnitude, while vector quantities have both magnitude and direction. Another difference between them is that scalar quantities have no direction, but vector quantities have a specified direction. Now, another difference between scalars and vectors is that scalar quantities are added arithmetically, while vector quantities are added or subtracted using vector rules. I will explain that. Now, what do I mean by adding them arithmetically and using vector rule? If you talk about scalar quantity, let's say speed. Now, if somebody moves a distance, or okay, let's use distance. If somebody moves a distance of 10 meters and then later move another distance of 5 meters, you can simply add them up by, if you want to get the resultant distance between the resultant distance or the net distance between the net distance, what do? 10 plus 5 will give what? 15. Very simple. You add them arithmetically. But if you talk about force, if this is an object and you apply a force of 5 Newton from this side and you apply another force of 10 Newton, what is the net force there? The net force is 10 minus 5, which gives you what? 5 Newton. Because why? This force will overcome this force by what? 5. So the net force acting on this body is what? 5. And you move this what? The direction of this force. This was arithmetical procedure. But if these forces are inclined at an angle, let me say this force, this is 5 Newton and this is 10 Newton, and this is an angle of 90. You cannot add them 5 plus 10, no. You use a method they call vector method or vector rule. That's why you cannot add vector quantities using normal arithmetic procedure. You need to make use of vector rule. And in vector, there are methods of solving vector quantities. You use the parallelogram method or parallelogram rule and the triangle or triangular rule or method. Now let's talk about another difference. Another difference between them is that examples of scalar quantities are speed, distance, time, energy, and so many other examples. Well, in vectors, we have examples like velocity, acceleration, displacement, and so many other examples. Now, in our subsequent videos or in the next video, we'll talk about addition and subtraction of vectors. I'm going to show you how we use vector rules, that is the triangular method and the parallelogram method, to solve or to add or subtract vectors. And also we're going to talk about how you resolve a vector or how you represent vectors in their components. Another difference there is that vector quantities, scalar quantities are represented by only values. They are represented by values and units. Scalar quantities are represented by values and units, while vector quantities are represented with arrows. For example, now you have a speed of 10 km per hour. 10 is a what? Value. 1 km per hour is what? The unit. So scalar quantities are represented by only values and what? Unit. While vector quantities are represented by arrows. Now, for example, now if this is a force, for a vector quantity, let's use force. The line here represents the magnitude. Let me say 10 Newton. And this arrowhead shows what? Direction. So another difference between vectors and scalars is that scalars are represented with values and units, but vector quantities are represented with arrows. Now, in my subsequent video, we are going to talk about how we add and subtract vectors using vector rule, which are the triangular method and the parallelogram method. If you learned anything in today's class, kindly do well to like, comment, and also subscribe if this is your first time. Now, also don't forget to turn on the notification button to be notified anytime I upload or release any other video. Thanks, and God bless you.